Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we're going to learn on the trigonometric identities. All right. So we'll do some kind of proving. I'll look at the double angle and also half angle. All right. So first, let's look at these basic trigonometric identities. All right. Actually, we have seen these in the trigonometric ratios. All right. But let's just do a revision. Suppose we have sine of negative a, so we'll get a negative sine of a because sine is actually an odd function. And then if cos of negative a, we'll get cos of a because cos is actually an even function, and also tangent of a, negative a will give us negative tangent of a because tangent is actually an odd function. We should know that tangent of a is actually given by sine of a divided by cos of a. All right, so how do I remember it? T equal to s over c. All right, and then we have secant of a, and then look at the third word, third letter here. All right, so it should be this one of 1 over cos of a, and this is the third letter is s, therefore we will have 1 over sine of a, and the one that is cotangent will get 1 over tangent of a, because tangent of a is given by this sine over cos. Of course, 1 over tangent of a will invert that one, will become cos of a over sine of a. All right, now we are done with that one. Next, for the identity number 8, suppose we have sine square a plus with cos square of a. All right, no matter what a is, as long as they are the same. All right, so this one will give us 1. All right, the values here is 1. And then if we have 1 plus tangent square of a, this one will give us a secant square of a. And then if we have 1 plus cotangent square of a, this one will give us cosecant square of a. All right, so we are done for the 10 identities now. And now we are going to look at the summation between two angles. All right, is we have sine of a plus minus b, therefore we will have sine of a sine of a cos b. All right, if it is plus minus, then it will be maintain plus minus. All right, so this one will give us cos of a sine of b. All right, but if you have cos of a plus minus b, and then we will have, all right, so this one will give us cos a cos b. But if it is plus minus, so therefore we will have a minus plus. All right, means that if it is positive, then what will be negative. If it is negative, that one will be a positive. Right, that one will give us negative plus of the sine of a sine of b. Right, and then we have that tangent of a plus minus b, therefore this one will give us tangent of a. If it is plus, then it will be plus. All right, so tangent of a plus minus tangent of b, this one is a fraction over 1 minus plus tangent of a tangent of b. All right, and then actually using the formula from 11, all right, so if both of them are a, all right, so we will have sine a cos a, this one cos a sine a, so we add them together, so sine of 2a will give us actually 2 sine of a cos a, right, using equation number 11. All right, and then if we use equation number 12, I guess, all right, so that one will give us, all right, cos square of a minus sine squared of a. And then we try to use the identities from, all right, so this one is actually number 50 now, it comes from 12. But if try to use identity number 8, therefore this one we are talking about the double angle. All right, so this one 14, 15 and 16 are double angle. All right, now we have if we try to put in identity number 8 inside this formula, therefore we give this one as 2 cos square of a minus 1, or 1 minus 2 sine square of a. And then if we have tangent of 2a, therefore using equation number 13, all right, identity number 13, therefore this one will give us tangent of 2a, right, so 2 tangent of a divided by 1 minus tangent square of a. All right, so that's basically the identities that you have to know when when solving this kind of trigonometric equation, trigonometric ratios, and so on. All right, so let's now prove some basic identities. Right, so let's have the first one here. Right, suppose we have to prove that a 2 cotangent of x over 1 plus cotangent square of x is actually equal to sine of 2x. So how to prove this one? Right, so maybe we just start with the cotangent of x. So we know that cotangent of x is actually 1 over tangent of x. So 1 tangent of x is actually given by cos of x over sine of x. So we'll just transform cotangent of x into cos x over sine of x. Therefore, we start with, all right, 2, all right, cotangent of x will become cos x over sine x. So that one is the numerator. Now I'm going to change the denominator into 1 plus, all right, so cotangent square of x. That means we will have, all right, cos of x over sine of x. So we have to square it, all right. So we have something like this, and then we have to simplify this. What do we call the denominator first? All right, so we'll have 2 cos x over sine of x. All right, so if you try to expand this one, so so of course when we try to expand this, what do you call square, so we will have cos square of x and sine square of x. All right, so we will have that one as, all right, so now I'm gonna make this one as a single fraction. Right, so how do I do that? So I'll just multiply this part with sine square of x over sine square of x. So I'll have sine square of x over sine square of x plus with cos square of x over sine square of x. Right, now because they have the same denominator for this one, all right, so we can combine it as a one fraction. Therefore we will have, all right, let's just write it here, 2 cos of x over sine of x. That one is for the denominator. So now let's look at the numerator. Sorry, that one is for the numerator. Now we're going to look at the denominator. Therefore we have sine square of x plus cos square of x divided by sine square of x. And we should recall the identity that we have sine square of x plus with cos square of x will become 1. All right, from the identities here. All right, so we use identity number 8 here. Therefore, we can substitute this part as 1. So we have, all right, let me just continue it here. Okay, I will have the numerator as 2 cos of x over sine of x. I should divide everything with 1 over sine square of x. And then when I have this one, this will give me, right, alright, so I'm gonna write this as 2 cos of x over sine of x. So of course this part will be, I'm gonna write it, instead of division, I'm gonna write it as multiply, and then I have to invert it to become sine square of x. Right now, we know that we can cancel this one, so we can cancel this square or become sine of x only. So we are left with this 2 cos of x sine of x, or you can even write 2 sine of x cos of x. So this is actually sine of 2x. Alright, so we have proved this one. Actually, there's a simpler way. I just realized that we can actually convert this one, right, using the identity. So 1 plus cotangent square of x is actually equal to, all right, so this one, cos x square of x. So this one is actually cos x square of x. So from, instead of doing this one, all right, instead of doing this, you can actually obtain cos x square of x, so we can convert into this. All right, so that's shorter way of proving this one. Right, so I hope you get the idea on how to prove these identities. So let's now look at this second question. Suppose we have this one. All right, so actually we try to write cotangent and tangent in form of cos x over sin x and sin x over cos x. So let's just start with sin of theta. All right, so I have cotangent is actually cos x over sine of x. We should be fast, eh? Right, so plus with sine of, sorry, that's not x, that one is theta, right? So we have theta there. All right, so I'm sorry, sine cos theta over sine theta plus with sine theta over cos theta. All right, so I start with this one. Now I'm gonna make this as a single fraction, therefore I have to cross multiply something like this. All right, so I will have, all right, so this one will become sine of theta. That one I'll get cos square of theta plus with sine square of theta, the whole thing over sine theta cos theta. All right, so sine theta over cos theta. We note that using the identities, this cos square of theta, all right, cos square, we recall the identities, cos square of theta plus sine square of theta, this one will give us 1. Therefore, we have this one as sine of theta. All right, this one will give us 1. 1 over, the whole thing is actually sine theta cos theta. All right, because they are multiplication, therefore you can simply cancel sine theta and sine theta. And then you are left with actually 1 over cos theta. And you know that 1 over cos theta is actually by identity given by secant theta. So we have proved this one. Simple, right? Not really difficult for this one. Let's look at this one. Suppose we have this, we need to prove this identity. All right, it's not that difficult. Let's just try this one. You start with secant of x. All right, so let's just secant. All right, I'll just write secant as 1 over cos of x. And actually tangent of x is actually sine of x over cos of x. All right, so this whole thing I'll have secant of x will give us 1 over cos of x minus tangent of x is actually sine of x over cos of x. All right, then I'm gonna make the numerator as a single fraction and the denominator as a single fraction. Therefore I have, all right, this one as 1 plus sine of x, the whole thing over cos x. All right, we add the fraction with the same denominator. All right, so this one we subtract the fraction with the same denominator. All right, so we have something like this. And then you have like 4-story fraction now. All right, pecahan 4 tingkat. So instead of using this pecahan 4 tingkat, you have to convert into 2 tingkats only, 2 tingkat only. So how? So 1 over sine of x over cos of x. So I'm gonna bring this one, all right, instead of division, I'm gonna write it as a fraction. Of if you can see clearly, so I'll just write, instead of fraction, I'm gonna write it as a division. So I have 1 minus sine of x over cos of x. I think you have learned this during your form 1 to convert from division of a fraction into a multiplication. Therefore you have to, you know, invert this one. This one will become something like this. All right, so we'll have something like 1 plus sine of x over cos of x. I'll multiply this one as, right, I'm gonna write it as cos of x over 1 minus sine of x. Right, by multiplication, because we can cancel the one at the top and also the one at the bottom here. So, and the numerator and denominator is cancelled here. Therefore, we are left with 1 plus sine of x divided by 1 minus sine of x. Actually, we have proved this identity. All right, so we are done with this one. Let's look at the last one here. All right, before I proceed with the half-angled formula. Suppose we have this one. All right, so what should we do? We should convert this tangent theta into sine theta over cos theta. So let's just try. All right, I'm going to write cos theta over 1 minus sine theta minus sine theta over cos theta. All right, now I'm going to write this as a single fraction. So what should I do? I should multiply this one something like this. All right, so I should multiply it something like this. So now I have it as cos square of theta minus sine square of theta multiplied with 1 minus sine theta. Sorry, that one should not be square. All right, you have sine of theta multiplied with 1 minus sine of theta, because I'm gonna bring this one multiply with this one. Right, now the whole thing divided by, all right, I'm not going to expand that one, so that one will become 1 minus sine theta in bracket cos theta, something like this. Right now I'm going to expand the numerator. So actually I'm going to expand this part, so be careful when I expand this part. So because this one will give us, all right, cos square of theta minus sine of theta, that one will give us plus sine square of theta. All right, be careful when expanding this one, because usually students forget to multiply negative with negative to become a positive. So this whole thing over, all right, so I'm gonna write that just in bracket. You don't have to expand that one. You'll see the reason why later. All right, so now I'm gonna use the, all right, let me just rewrite this one, rearrange this cos squared theta plus sine squared theta minus sine theta, all right? So this whole thing over 1 minus sine of theta cos of theta, and just you just need to recall the identity that we have. Sine squared theta plus cos squared theta is actually equal to 1, therefore you should note that this one will become 1. So now I have that one as 1 minus sine theta, this whole thing over 1 minus sine theta cos theta. All right, so if you can see this clearly, 1 minus sine theta and 1 minus sine theta can be cancelled out, all right, because they are the same term. All right, so we can cancel this. This one will become 1 over cos of theta. So 1 over cos of theta is actually secant of theta. So we have proved this identity. Right, so this is the reason why I do not expand this one. All right, I do not expand it, because I want to cancel 1 minus sine theta together with 1 minus sine theta at the numerator, also at the denominator. All right, so let's now look at the half angle formula for the trigonometric identities. All right, so actually from the double angle formula, we have cos of 2 theta is equal to this one, and this one. But I'm gonna use the second one and the third one. Suppose I have for the second one, all right, so I have actually 2 cos squared theta minus 1 equal to cos of 2 theta. And then I'm gonna make cos theta as the subject, therefore I'm gonna bring that negative 1 to the right side, therefore I have cos of 2 theta plus 1. And then I have cos square of theta, which is given by cos of 2 theta plus 1, the whole thing divided by 2. So if I want to have what we call cos of theta, all right, therefore I have to take square root on the right side, right? Therefore I have cos of 2 theta plus 1 divided by 2. Therefore when it involves square root, so it should be plus minus that. All right, now this one, all right, so let's just look at this theta here, all right, is actually half of 2 theta. All right, so I'm gonna write theta is actually half of 2 theta. What about theta over 2? It should be, it's actually half of theta. If you proceed with theta over 4, it's actually half of theta over 2. Right, so if you have actually this one, theta is half of 2 theta, therefore theta over 2 should be half of theta. So now I'm going to change this into cos of, alright, I'm going to change this theta into theta over 2. So of course this one will be changed here. Alright, so instead of 2 theta now it become theta, because theta is half of 2 theta, therefore theta over 2 should be half of theta. Alright, plus 1 divided by 2. So you got the formula for the cos of theta over 2. Now you're going to proceed with the formula for the sine of theta over 2. So actually you have to use the third formula here. Suppose I start with the cos of 2 theta given by 1 minus 2 sine square of theta. Alright, now I'm gonna write 2 sine square of theta is actually 1 minus cos of 2 theta. So I have sine square of theta, which is given by 1 minus cos of 2 theta, the whole thing divided by 2. And please, there's no such thing as cancelling 2 like this. No, there's no such thing. Please remember. Right now, I'm gonna make it as a sine theta. Therefore, I'm gonna have a plus minus square root of this right side now. Alright, over 2. Again, since it is actually theta is half of 2 theta, therefore if I want to have sine of theta over 2, of course it should be half of the 1 minus cos of theta over 2. I'm just changing the parameter or the variable here. Alright, so we get a formula for the cos of theta over 2 and sine of theta over 2. And the last formula that can be obtained is actually the formula for the third one, which is tangent of theta over 2. So how do I get this one? This one is given by the formula sine of theta over 2 divided by cos of theta over 2. So how do I do this? So of course I'm going to substitute the formula for sine theta over 2 and cos of theta over 2. Therefore, alright, since both of them involve the plus minus, so of course I'm going to write tangent theta as a plus minus, but I'm going to write it in the middle. Alright, so it'll be something like plus minus, and then that square root of for the sine of theta over 2 will give us 1 minus cos of theta over 2 divided by with the cos of theta over 2 will become cos of theta plus 1 over 2. Alright, so you should know the properties for the third, which is square root of x divided by square root of y can be written as square root of x over y. Therefore, I have this one as plus minus, alright, square root of the whole thing here. Right, I'm gonna have two fractions, alright, and the numerator will be 1 minus cos of theta divided by 2. And the denominator will become cos of theta plus 1 divided by 2. Therefore, instead of division, I'm going to change it into multiplication, something like this. Alright, so 1 minus cos of theta over 2. And then I'm going to write this part, alright, because it divides that one. So I'm going to write it as a multiply. That one will change to become 2 over cos of theta plus 1. Next, we can cancel 2 with 2. Therefore, we are left with the plus minus square root of, alright, so 1 minus cos of theta over cos of theta plus 1. So we already obtained the formula for the tangent of theta over 2. So we have obtained 3 formulas here, the first one, the second one, and the third one. So this is basically the half angle formula, but it is actually rarely used in the proving, but at least you get the idea on how to get this half angle formula. Alright, so that's it for this video. Thank you for watching it. See you again